Suppose 40% of people support a recent action taken by the U.S. president. If 6 people are randomly chosen, find the probability that half of them support the action. Okay, so we need to recognize this as a binomial. We have 6 trials, so n equals 6. We have a success or failure. We can classify as they either support the action or they don't. So we have a success or failure. Probability of success is 40% or 0.4. So the probability of failure would be 0.6 or 60%. And then we can treat the trials as independent because we're looking at a large group of people here. So 40% of people, we're just assuming they're in the U.S. So again, there's millions and millions of people to choose from. So we can treat them as independent. Okay, so we have a binomial situation here. So if 6 people are randomly chosen, probability that half of them support the action. Well, half of 6 is 3. So what we're looking for is the probability of exactly 3. And with the binomial formula, the probability of exactly 3, out of 6 people, you want to choose 3 successes. So that's 6C3. The probability of success on any single person you choose is 0.4, and you need 3 of them. Probability of failure in any single draw is 0.6, and you need 3 of those. So if you go through and do that arithmetic, you end up with 2765. Okay, on the next one, 12 people are chosen. Find probability that 3 support the action. So I'm going to show the answer to this because it's just straight up using the binomial formula. And you can pause the video if you need to, but I'm going to show the answer so we can keep moving. And then moving on to the next one. Number 3, it gets a little trickier because of the wording. We're choosing 10 people. We want to find the probability that less than 2 support the action. Well, now this is a little bit different because less than 2 could be how many? Well, less than 2 could be 0 or 1. So now we have an or, so that's the addition rule. You need to find the probability of 0 and add the probability of exactly 1. So you take the probability of 0 plus the probability of exactly 1. So this is applying this binomial formula twice. Okay, and I'll show the answer for that so you can see what you get. Okay, so this first part here is having exactly 0 people support the action. And then this part here is having exactly 1 support the action. Add those together, you get about 4.6%. Okay, so using your calculator, to find the probability of exactly X successes in N trials, we press second vars, and then binom PDF, and then NPX. Okay, that looks confusing, but when you see the steps, it'll be fairly straightforward. Okay, so rather than doing all this by hand, let's just look at number 2. So we chose 12 people. We want to find exactly 3 supporting the action. So if we follow the directions, we press second vars. You see how it says DISTR above that? That stands for distribution. So we want to have a binomial distribution. So if we scroll down to option 0, okay, really 10, we get binom PDF. There's also a binom CDF, which I'll explain in a minute. When we want to find exactly, in this case, not exactly 3 successes, or 3 right-handed, we want to choose PDF. Okay, exactly is the keyword you're looking for to use the PDF. Okay, so we choose binom PDF. We put in the number of people we're choosing, which is in this case, 12. Okay, so n is 12. Okay, because I'm doing number 2. Okay, so n is 12, and then comma, we put in the probability of success, which is 0.4. And then how many of those successes do we want? We want exactly 3 of them. I'll end the parentheses. Your operating system may be slightly different. You might have when you do choosing the Binomial PDF, it might have NP and X listed out that you just enter the values in for those. So your operating system may be slightly different. Same idea though. Okay, and we get 0.141893. So if we round it to 4 decimal places, which is usually what you round probability to in this class, we round that to 0.1419. Okay, so we can see how we get that using the calculator. Okay, if we choose the Binomial CDF, okay, Binomial CDF, the C stands for cumulative. So now with the Binomial CDF, that'll show the cumulative probabilities from x equals 0 through whatever number you put in for x, including the value put in for x. And that Binomial CDF feature is very useful when you need to find a range of successes. So if we look at that third one, less than 2 could have been 0 or 1. So if we use the Binomial CDF, because there's more than one formula, more than one time we have to use the formula. So if we find the cumulative probability from 0 to 1, then that'll give us our answer. So second vars, and then if we scroll to Binomial CDF, now we're choosing 10 people. So 10, comma, the probability of success is still 0.4. And now, whatever number I put in, it's going to find the probability of finding 0 through and including the number I put in. Well, I want to find 0 through 1, so I'll put 1 in. And then that'll give me the probability. Now, because of the Binomial CDF on your calculator is a little more exact than what I rounded to here. Okay, so 0.0464 is what your calculator would round it to. I have 0.0463. Okay, but very close to the same probability. Okay, so in another example, in a large city, a murder is committed. There's 12 jurors, could be randomly selected. And we're going to suppose that a quarter of its jury pool consists of college graduates. Find the probability that less than half of the jury consists of college graduates. And again, I don't want to gloss over the idea that you need to identify this as a binomial situation. They're either a college graduate or they're not. We have a fixed number of trials because we're choosing 12 people. We can classify success as getting a college graduate. When you choose a juror, if they're a college graduate, that's a success. Not a college graduate will be a failure. And then we look at independence. Well, independence, we can say it's a large city, so we can assume independence, even though technically it isn't quite independent. Okay, we can find the probability of success of being 0.25 and failure 0.75. Okay, so find the probability that less than half of the jury consists of college graduates. Well, we're choosing 12 people, or 12 jurors, to get less than half of them being college graduates. That could be 0, 1, 2, 3, 4, or 5. Because half would be 6, so less than half would mean less than 6. Okay, so our random variable x has to be less than 6. So if we want to use just the binomial formula, we'd have to find the probability of 0, the probability of 1, the probability of 2, all the way up to the probability of 5, and then add them all together. So that would be a lot of work that we don't need to do. We can use the calculator. So using the calculator, this will be a cumulative probability from 0 through 5, because we want to find less than half. So that's 0 through 5. So that's a binomial CDF. 12 jurors, probability of success is 0.25, and we want to go through 5 of them. So because of the CDF, that's finding 0 through 5. We don't put a 6 there. This is the thing the students miss the most. You do not put a 6 there because less than half implies that 6 is not included in less than half. Okay, so when you do that in your calculator, you get 0.9456 using the steps I just showed you. Okay, the next one, the probability that less than 8 college graduates are on the jury. Well, less than 8 could be 0, 1, 2, 3, 4, 5, 6, or 7. So x has to be less than 8. So that means we want to find our cumulative probability from 0 through 7. So we do binomial CDF. 12 jurors, probability of success in any single juror is 0.25, and we want to end at 7. So that gives us 0.9972. Okay, going on to the next one. Okay, I'm going through this rather quickly, but you can pause the video if you need to stop and think a little bit, or try them on your own. The probability of getting no more than 4 college graduates. Well, no more than 4 would mean 0 through 4. So that would be x is less than or equal to 4. So the number of graduates is less than or equal to 4. So here's a case where we want to include 4. So we want to find the binomial CDF up to 4 and including 4. Okay, part D. This is probably the toughest type. Find the probability that at least 4 college graduates are on the jury. So at least 4. You have to really pay attention to that wording. At least is not the same thing than less than 4. At least 4, you want to think about at least 4 being how many. And one thing that will sometimes help students is if you start running into a problem of trying to figure out, well, how many could there be? Could I be choosing? How many successes do I want to choose? You can list out all the possibilities. All the possibilities for the number of jurors is 0, for the number of college graduates on the jury are 0 through 12. If you list them all out, at least 4 means 4 or higher. So here we can have 4, 5, 6, 7, 8, 9, 10, 11, or 12. So we want to find the probability that x is greater than or equal to 4. Now the problem here is, and this is why I said this one is a little tougher, notice how we are on the right end of our possibilities here. When we use binomial CDF, that finds the probability of 0 through whatever number you put in for x. There is no calculator function to find the probability starting at 4 and ending at 12. So what we have to do is we have to use the complement idea. Okay, the complement meaning, can we find from 0 through 3, and once we know that, we can subtract it from 1 to get what's left over. So just say, for example, that the probability of getting 0 through 3, let's just say it was 0.2 or 20%, then what's left over would have to be 80%. If the probability of 0 through 3 was 40%, then what's left over would have to be 60%. Okay, so here, if we do the binomial CDF and subtract it from 1, using the complement idea, we can get our answer. Okay, so notice the binomial CDF that I'm doing here. We have 12 jurors, 0.25 probability of success, and we have 3 that we're going to end at. So that'll find the probability from 0 through 3. To find the remaining probability, you subtract that answer from 1. And you end up with 0.3512. Okay, and then the last one. Oops, I'm sorry, not the last one. Find the probability that more than 3 college graduates are on the jury. Well, again, think about more than 3 could be how many? Well, if you list them out again, more than 3, so list out 0 through 12, more than 3 could be 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, what you might notice there is, that's the same thing as the last problem. So x is greater than 3 is the same thing as x is greater than or equal to 4. Because you can't choose like 3.2 or 3.75 college graduates. You have to choose a whole number of college graduates. So those probabilities are the same thing. Okay, the last one. Find the probability that at least 1 college graduate's on the jury. Well, at least 1, if you listed them out again, you could look at that as at least 1 being 1 through 12. Well, notice that 0 is the only thing missing there from that. So if you found the probability of 0 and subtracted that from 1, you would find the total probability. Now, the probability of exactly 0, you can just use straight up multiplication rule. You could also use binomial. If you use the binomial for that, you could plug in 0 successes and 12 failures, which is really just 0.75 to the 12th. Okay, so when you do the complement 1 minus that, will give you 0.9683. So there's almost a 97% chance that there'd at least be 1 college graduate on the jury.